is Dr. V. Anitha Rani, Associate Professor, Department of Chemistry from Institute of Aeronautical Engineering. So today we are going to discuss about course description. So name of the course is Chemistry, course code AHSC06, program BTech, semester 1 and 2. So we are going to discuss outcome based education and Bloom's taxonomy, course overview, course objectives, course outcomes, program specific outcomes, course syllabus. What is outcome based education? Outcome based education or OBE is a student centric educational that maps and measures student performance at every step. So what is OBE means? It is student centric education that maps and measures student performance at every step. The OBE model aims to maximize student learning outcomes by developing their knowledge and skills. So what the student is developing is knowledge and skills by the outcome based education. So what are the characteristics of outcome based education? So there are three characteristics are there on outcome based education. So the first one is practical, second one fundamental, and third one reflect. So here practical, here knowing how to do things, ability to make a decision. So here the student will learn the concept, they will learn in practical way, means they will do the experiments, they will learn here the concept in by doing the practicals. Fundamental. So students will gain the knowledge. Students will gain the knowledge about the course. So understanding what you are doing and why here the students means what we are going to learn the fundamentals in the course. So reflective, learn and adapt through self-reflection, apply knowledge appropriately. Means after learning the concept, after learning the theory, after learning the course, so they have to go for application. So they will apply. So here the characteristics of outcome based education is, so first one practical. So students will learn the here knowledge, means they will learn the concept here through practicals, and also fundamentals they will learn, and also so they will learn the what they learned so they can apply. So what is Bloom's taxonomy? So what is outcome based education means? It is the outcome based education means it is a student centric educational model that maps and measures the student performance at every step. Now here we have to follow the Bloom's taxonomy. The taxonomy of educational objectives known as Bloom's taxonomy is one of the most recognized learning theories in the field of education. So it is the common language for the educator. Okay. So here educators often use the Bloom's taxonomy to create learning outcomes. That target not only subject matter, but also the depth of learning. They want students to achieve. So the teachers, so they will follow the Bloom's taxonomy for learning objectives, not only for subject matter, but also the depth of the learning they want students to achieve. And to then create assessments that accurately report on students' progress towards the outcomes. Okay, we can see the progress of what we are learning for the students, the learning outcomes, the progress towards these outcomes. So here Bloom's taxonomy comprises 3 learning domains. So there are 3 learning domains in Bloom's taxonomy. So the first one is cognitive, second one affective, third one psychomotor. And these 3 and assigns to each of these domains here that corresponds to different levels of learning. So it's important to note that the different levels of thinking defined within each domain of the taxonomy and hierarchical. So Bloom's taxonomy is a powerful tool to help develop Learning objectives. So we can develop learning objectives because it explains the process of learning. So it explains the process of learning. So we can frame learning objectives, we can frame learning outcomes by following the Bloom's taxonomy. So before you can understand the concept, you must remember it. So in Bloom's taxonomy, so how many levels will be there means, so there will be 6 levels will be there. So first level is remembering, so second level is understanding, third level applying, fourth level analyzing, fifth level evaluating, and sixth level creating. So here, before you can understand the concept, you must remember it. So the lowest level is remember. So the students have to remember before understanding the concept. So to apply the concept in a new way, you must first understand it. So whatever, for example, in chemistry, we will teach galvanic cell. So the students have to learn how here the concept means they have to learn here how the chemical reactions taking place in galvanic cell. So here, before you can understand the concept, you must remember it. The basic means the definitions of electrochemical cell. You have to remember it. To apply a concept, you must first understand it. If you know how these chemical reactions are taking place in a galvanic cell, then only you can apply it. You can apply it where? In batteries. So in order to evaluate process, you must have analyzed it. So after applying, what the students will do? Analyzing. Means breaking the here one whole part into some small parts. Again, they have to frame it into a one part. Means they must have that analyzation. So to do that what they learned. So in order to evaluate a process, means before going for evaluation, the students have to analyze. So all these levels here in Bloom's taxonomy that will helpful to the students and also teachers. So first one is remembering, recalling relevant knowledge from long-term memory. Understanding, make sense of what you have learned. So they have to understand the concept. Apply, use the knowledge gained in a new way. So what they learned the concept, they have to apply in a new way. Analyzing, breaking the concept into parts and understand how each part is related to one another. Means in a galvanic cell, so we can take different parts. So anodic half cell, cathodic half cell, how the battery works. So when we combine these half cells and connecting to the voltmeter, means then functioning starts here. So breaking the concept into parts and understand how each part is related to one another. Making judgments based on a set of guidelines. Evaluating means making judgment. So student have to make a judgment based on a set of guidelines. Creating. So putting information together in an innovative way. So creating something, it should be a new one, means putting information together in a innovative way. So now in chemistry, first we have to discuss about course overview. So this course discusses elements and compounds and their applied industrial applications. It deals with the topics such as batteries, corrosion, and control of metallic materials, and water and its treatment for different purpose, and engineering materials such as plastics, elastomers, and biodegradable polymers, and their preparation, properties, and applications. And next, energy sources and environmental science. So these are the topics we are going to, means these are completely like a 5 modules. So this we are going to discuss in course chemistry. So sustainable chemistry, so that focuses on the design of the products and processes that minimize or eliminate the use and generation of hazardous substances is also included. So here we will discuss in chemistry about green chemistry. So we will discuss about how we can prepare useful products in a without eliminating any hazardous substances. So course objectives. The students will try to learn. So the teacher will frame the course objectives. So what the students will try to learn. So the students will try to learn the concepts of electrochemical principles and causes of corrosion in a new development and breakthrough efficiently in engineering and technology. So this is the first objective. So that we are taking that about it. We are discussing here about the students will try to learn about electrochemistry and corrosion. So next is the different parameters to remove causes of hardness of water and their reactions towards the complexometric method. So students will try to learn here about hardness of water by EDTA method, complexometric method. Next one, the polymerization reactions with respect to mechanisms and its significance in industrial applications. So students will try to learn here polymerization reactions and their applications. Next, fourth one, the significance of green chemistry to reduce pollution in environment by using natural resources. So here we will prepare the chemical products here without eliminating any hazardous. Here there won't be any hazardous substance eliminated here because here we are using natural resources. So course outcomes. So course objectives are 4 and course outcomes here after successful completion of the course, the students will be able to do. After successful completion of the course, the students will be able to do here, able to recall first one, CO1, course outcome. CO1, recall the operation of electrochemical systems for the production of electrical energy, that is batteries. So first here course outcome is recalling here about working of electrochemical systems and how production of electricity will be taking place by this electromotive process. So here knowledge level, it comes under when we take Bloom's taxonomy level, here it comes the students are recalling about this electrochemical systems. So that's what we have given here, the Bloom's taxonomy level. Remember, the CO2 is utilize electrochemical cell parameters, electrochemical active surface area, current and over potential under given condition for calculating the electromotive force and electrode potential. So we can calculate after learning about here about electrochemical cell, then we can about Nernst equation, then we can take the formulas and we can calculate the about EMF, we can calculate EMF of the cell, and also we can calculate here electrode potential of half cells. So we take here, we are calculating by using the formulas here, EMF of the cell. So we will write here in Bloom's taxonomy, apply. Now CO3 is explain the chemical and electrochemical corrosion in metals by influencing the nature of environment. So here the students learned here about chemical and electrochemical corrosion. Here how metal is undergoing dry atmosphere and wet atmosphere. So that is by influencing the nature of environment. Means when metal is exposed to the environment, how the metals are undergoing corrosion. How here learned about different types of corrosion. So we can write here Bloom's taxonomy. The students are here they're understanding in a different way. So what is chemical corrosion? What is electrochemical corrosion? So we have given here understanding. CO4, make use of the basic electrochemical knowledge of corrosion process and apply the concept for protection of different metals from corrosion. So after learning about corrosion of metals, and here we have to go for how to protect the corrosion, we have to go for how to control the corrosion by taking the protective methods. So we are applying now, so we are giving here Bloom's taxonomy level, that is apply. CO5, describe the hardness of water for finding the hardness causing salt in water. So here student learned here about hardness of water and how can find out hardness of water, means how to calculate the hardness of water. They can easily find out hardness causing salts in water. So the students are understanding what are the salts present in water, what are the hardness causing salts present in water. So they will understand. So that we are writing here, understand. Then CO6 here, utilize the main desalination process. Desalination process. This is one of the treatment method for producing potable water for saline or brackish water. So here we are going for utilization of the treatment methods here to produce a soft water. So we are giving here apply. So CO7 describe different types of polymerization reactions for synthesizing polymers from monomers. So here we can go for preparation of the polymers by taking different mechanisms. Student understood here about different types of polymerization. So we wrote here understand. So next CO8 classify different types of lubricants and their mechanism for understanding to reduce friction between two moving surfaces. So here we can students understood clearly about different types of lubricants and mechanism, means in which missions lightweight missions will be there, heavy missions will be there. So how to apply the oils in these missions, students will understand easily. They will understand easily by different mechanism. So we have given here understand. So next CO9 explain the importance of green synthesis for understanding to minimize the generation of hazardous substance. So the student understood about the importance of green synthesis for understanding to minimize, how to minimize the generation of hazardous substances by using green solvents in green synthesis when we prepare chemical products. So we have given understand. CO10 choose different types of solid, liquid and gaseous fuels in terms of calorific value for utilizing in industries and automobiles. So here we wrote here apply Bloom's taxonomy, because after discussing here about solid, liquid, gaseous fuel, then how we can apply, how we can utilize these different types of fuels. Here we can use in industries and automobiles. For example, we are using here liquid fuel, petrol, diesel, we are using in the vehicles. CO11 classify different types of natural resources and their applicability for understanding the proper utilization of non-renewable resources. So here we discussed about natural resources, and here how we are applying that for understanding the proper utilization of non-renewable resources. So we learned here in natural resources about renewable resources and non-renewable resources, and we will come to know now how properly we have to utilize the non-renewable resources, because they are here exhaustible resources. So we have to use it carefully. So we wrote here understand. So CO12 describe the effect of pollutants in air, water and soil that causes the environmental pollution. So students understood here about the pollutants. What are the pollutants that is causing air pollution? Pollutants causing water pollution and pollutants causing soil pollution. So that is leading to the the polluting the environment. So we have given here Bloom's taxonomy, understand. So program outcomes, just we can tell here we are taking in a briefly program outcomes. So first one engineering knowledge, second one program analysis, problem analysis, third one design or development of solutions, fourth one conduct investigations of complex problems, and here fifth one modern tool usage, sixth one engineer and society, seventh one environment and sustainability, eighth one ethics, next ninth one individual and teamwork, and 10th one communication, 11th one project management and finance, 12th one lifelong learning. So these are 12 program outcomes. And now for chemistry course, which of the program outcome is so that we can map to the chemistry course that we have to see. So here for chemistry course, PO1 we can map, that is students learned, they will gain the knowledge, engineering knowledge, and we can map PO2 also problem analysis, because there will be problems at there. So students will learn about numerical problems based on the concepts. Next we have selected PO7 because students will learn here how environment is polluted and so CO7 is environment and sustainability, and they will learn about green chemistry also. So PO1 is what is PO1 means? It is apply the knowledge of mathematics, science, engineering fundamentals, and engineering specialization to the solution of complex engineering problems. So based on here overall we can tell PO1 is, that is engineering knowledge. So first here number of vital features are there. So first one is knowledge, understanding and application of scientific principles and methodology. So second one mathematical principles. Third one, that is the here own and or here we can take engineering disciplines to integrate, support study of their own engineering discipline. So here when we are taking each module here in chemistry, we have to see that here how many vital features are mapping with the COs are mapping with the P. So next one is PO2, identify, formulate, review research literature and analyze complex engineering problems reaching sustained here substantiated conclusions using first principles of mathematics, natural science and engineering science. So base PO2 is that is based on problem analysis. So number of vital features here it is taken 10. One is here vital feature 1 is problem or opportunity identification. Problem 2, problem statement and system definition. 2, 3 is problem formulation and abstraction. And fourth one is information and data collection. Fifth one is model translation. Sixth one validation. Seventh one experimental design. Eighth one solution development or experimentation or we can take implementation. Ninth one interpretation of results. 10th one documentation. So PO2 here how many number of vital features are mapping with course chemistry, that we have to see and we have to map with the COs and P. Next one PO7, understand the impact of the professional engineering solutions in societal and environmental context and demonstrate the knowledge of and need for sustainable development. So PO7 is based on environment and sustainability. The number of vital features are impact of the professional engineering solutions, and here we can take socio-economic and political. Third one is political and environmental. And here we have to see that how many taking PO7. So in which of the what we are taking the modules. So which module. So we can take the name of the module, for example, natural resources and environmental pollution. So how many number of vital features? Here it is mapping with the COs to PO7. So here we have taken PO1, engineering knowledge. Apply the knowledge of mathematics, science, engineering fundamentals and an engineering specialization to the solution of complex engineering problems. So here we have given strength 3 because the students learned here, they will learn here about the basic concepts of like electrochemistry, corrosion, polymers and they will learn about here fuels. So we have given here 3. So PO2, problem analysis, identify, formulate, review, research, literature and analyze complex engineering problems reaching sustained conclusions using first principles of mathematics, natural science and engineering sciences. So PO2, so we have given the strength is 2 because all the 5 models are we are not discussing the problems. So which of the models we are discussing the problems, in that only we are giving strength, based on that we are giving the strength. So we got 2. So PO7, environment and sustainability, understand the impact of the professional engineering solutions in societal and environmental context and demonstrate the knowledge of and need for sustainable development. So here the students they understood about the concept environment, natural resources and environmental pollution. So we have given PO7, that is 3. Strength is 3. So here when we take all the branches like computer science and engineering, and here we can take information and technology. and mechanical engineering, civil engineering. When we take all the branches, all the departments, so they have program specific outcomes. So how this chemistry course is here, how we can give the strength to they taking departmental level, taking the program specific outcomes, so we can take the strength. So here specific program specific outcomes. So ours is here basic basic course. So we have to go. We cannot go there high level here. For example, if we are taking computer science and engineering, so we cannot give strength level to their level. So we have not given here strength. So first one is professional skills, the ability to understand, analyze, and develop computer programs in the areas related to algorithms, system software, multimedia, web design, big data analytics, and networking for efficient design of computer-based systems of varying complexity. So next, PSO2, problem solving skills, the ability to apply standard practices and strategies in software project development using open-ended program environments to deliver a quality product for business success. PSO3 is successful career and entrepreneurship, the ability to employ modern computer languages, environments, and platforms in creating innovative career paths to be an entrepreneur and just for higher studies. So here, justifications for COPO or PSO mapping. We are going for justification of COPO mapping. So course outcome CO1. So when we are taking PO, when we are taking program outcomes PO1, so justification for mapping. So the students will be able to understand the operation of electrochemical cell systems. So that is, they are gaining knowledge for producing electrical energy. Means by chemical reactions, electrical energy is produced. So they understand that one, and derive mathematical expressions for Nernst equation using principles of science and mathematics for solving engineering problems. So they will learn derivation of Nernst equation, and they can do problems on that by applying the formulas. So we have given here 3. Number of key competencies 3. So here already I have given vital features. So for PO1, 3 are there. So all the 3 are we are giving a justification of CO and CO1, PO1, because first one is knowledge, understanding and application of scientific principles and methodology. Second one, mathematical principles, and that they learned about the formulas about Nernst equation. Third one is engineering disciplines to integrate study of their own engineering discipline. So I gave here 3. Next, CO2, PO1, describe electrode potential, standard electrode potential, and reference electrodes. They will learn about standard electrode potentials. So knowledge to find out electrode potential of different electrodes, pH of unknown solutions by applying mathematical expressions. Here they will understand about how to find electrode potentials. They will understand, and by applying mathematical expressions for electrode potential using principles of science and mathematics for solving engineering problems. So here they will go for principles of science and mathematics. They will use the formulas. They will do the problems. Okay. So we have given number of vital features 3. Next, PO2, program outcome PO2. Identify the problem formulation and abstraction for calculating electrode potential under non-standard conditions by applying Nernst equation from the provided information. Means students will get the problem. Information is provided. What they do? They will remember. They know the formulas. So they will take the formulas. So they will apply the values in that formula. They will calculate the here electrode potential. They will calculate under non-standard conditions by applying Nernst equation. So we have given number of vital features too, because here we can see number of vital features 10 are there, but here we can take only a 4th one, information and data collection, and problem or opportunity identification, problem identification. So next one, CO3, PO1. Understand the electrochemical knowledge of corrosion process. So they will learn about corrosion process knowledge, in which metals convert into metallic oxides. So the students will understand how metal is converting into metallic oxide. Means when metal is exposed to the environment, here the metal is having a layer that is known as metallic oxide. They will understand about that, how that layer is formed on the surface of the metal. By exposing to environment, so they will understand about that. For solving engineering problems by applying the principles of science. So here they will learn, students are not learning about derivation part or mathematics, any formulas. So we are giving number of vital features only 2. So PO7 is for CO3, PO7 we are mapping. Explain the chemical and electrochemical corrosion in metals by influencing the nature of environment. Means here the students are learning that types of corrosion. There are 2 types of corrosion, dry corrosion, wet corrosion. Here how metal is undergoing corrosion by exposing to the environment. They will gain the knowledge and understand they will understand here about the how dry corrosion is taking place, how wet corrosion is taking place. So understanding the impact in socio-economic and environmental context for sustainable development. So we'll understand about different types of corrosion. We are giving only 2 because here no problems are there, no formulas are there. So they no need to apply here any mathematical expressions. So we have given number of vital features to CO4, PO1, mapping to PO1. Apply the corrosion control methods like metallic coatings, cathodic protection to prevent corrosion in different metals for solving engineering problems by applying the principles of science. So CO4 we are taking that is the apply the corrosion control methods. So there are different control methods like metallic coatings, that is surface coatings, cathodic protection to prevent corrosion in different metals for solving engineering problems by applying the principles of science. So here we are taking PO1 only number of vital features 2 because here also students will gain the knowledge and they will understand how we can protect the metals without undergoing corrosion by taking here different methods like metallic coatings and cathodic protection. So next CO5, PO1, describe the hardness of water. That is students are learning, they got the knowledge about what is hardness of water. For finding the hardness causing salts in water. So the students will learn what are the salts are there, what are the different types of salts, temporary salts, permanent salts present in water. They will understand. By applying mathematical expressions for finding hardness of water using principles of science and mathematics for solving engineering problems. So here students will apply here the formula, here hardness causing salts formula they will apply. They will find out here hardness for they will find out hardness for hardness causing salts present in water. So we are giving number of vital features here 3. So next CO5 we are taking mapping with PO2. Identify the problem and formulate for finding the hardness of water in terms of calcium carbonate equivalents with given information and data by applying principles of science. So students will find the hardness of water by applying the formula. We are taking the formula in terms of calcium carbonate equivalents. So they will understand because all the hard salts present in water, they are in dissolved condition. Then how to find out hardness of water? So they will understand the formula. They will understand very clearly about how we are taking the formula is in terms of calcium carbonate equivalents. So we have given number of vital features here too, because students will identify the problem. So they will hear what we are giving the problem, what is we are giving the data and information. They will see that they will apply in the formula. So next one, CO6, we are mapping with PO1. Describe various treatment methods. So they will learn different treatment methods, knowledge to produce soft water and to find total hardness in hard water. So they will find out hardness in hard water. So understanding. By applying mathematical expressions for finding hardness of water using principles of science and mathematics for solving engineering problems. So here also students for CO6, so they are calculating here PO1 we are taking. What they are doing means they are learning here different methods and they will apply the formulas. For example, EDTA method. They will apply the formulas and they will find out the hardness in water. So we are given number of vital features there. So CO7 mapping with PO1. CO7 is course outcomes. That is 7 is understand the polymers and gaining knowledge. That is what is a polymer by polymerization reactions. How polymer is prepared here by polymerization reactions. Different properties. What are the properties of polymers? Properties for plastics and elastomers. So we will they learned about plastics. They will learn about elastomers, rubbers. So they will understand what is a plastic, what is elastomer, and they will understand about that for solving engineering problems by applying the principles of science. So we are giving number of vital features to here because there are no problems here. So we are giving no mathematical expression. So we are giving only 2. CO8 mapping with PO1. Apply the polymeric materials. So knowing about students are gaining knowledge for different domain of sciences, technologies and industry. So they will understand. They will understand. So plastics we are using for domestic purpose industries. Elastomers, rubbers we are using for domestic purpose and industrial purpose. So different domain of science, technologies and industry. They will understand about that here about polymers. For solving engineering problems by applying the principles of science. So here we are giving number of vital features to mapping with CO8 to PO1 because here no formulas, no problems are there. So no mathematical expression. CO9 mapping with PO1. Explain the importance of green synthesis. Learning, they are gaining knowledge. So what is green chemistry? What is green synthesis? For understanding to minimize or eliminate the use and generation of hazardous substances for solving engineering problems by applying the principles of science. So they will gain the knowledge, they will understand. They will understand the concept of green chemistry, green synthesis, how chemical products are, we are preparing the chemical products by following green synthesis here. So we are giving number of vital features to here. Here also no mathematical expression, no formulas. CO10 mapping with PO1. Understand different types of solid, liquid and gaseous fuels. So students will get the knowledge. What is solid fuel? What is liquid fuel? What is gaseous fuel? With their characteristics and calorific value. So here what students learned here, what students will learn here, what is the calorific value of solid fuel? Means how much heat it can liberate, how much heat liquid fuels are liberating, how much heat gaseous fuels are liberating. So they can go for variation of different calorific values of solid, liquid, gaseous fuels. They will understand. By applying mathematical expressions for finding calorific value using principles of science and mathematics for solving engineering problems. So here they will apply the calorific value that formulas they will apply. So they will understand here they will find out the calorific value of fuels. So we have given number of vital features 3. So CO10 mapping with PO2. Identify the given problem and formulate for finding the calorific value of fuel with a given information and data by applying principles of science. Here given number of vital features 2. So here we are giving the problem. So students will identify the problem and they will collect the what data we are giving, what information we have given in the problem. They will collect that. They will apply the formula. They will solve the problem. CO11 mapping with PO1. Describe living and non-living resources. So that is they'll gained knowledge. That is what is living resource, what is non-living resource, and the utility of these resources. How we can use these resources. They will understand about water resources, land resources, and here renewable resources, non-renewable resources that are called energy resource. They will understand. And for solving engineering problems by applying the principles of science. So here also we are mapping CO11 to PO1, number of vital features 2, because here also no problems are there. CO11, no mathematical expression. CO11 mapping with the PO7. Describe the renewable and non-renewable resources, alternate energy resources. They will gain the knowledge that is what is the renewable resources, what are the non-renewable resources, and understand the impact. Means they will learn here about after learning the renewable, non-renewable resources, and they will understand that how we can utilize that, means how we can use alternate energy resources. What are the advantages are there? What are the disadvantages are there? So understand impact in socio-economic and environmental context for sustainable development. So here we are mapping here CO11 with PO7. We are giving number of vital features here too, because here also no formulas are there, no mathematical expression. CO12 mapping with PO1. Understand the effect of pollutants on air, water and soil. So they will learn, they will gain the knowledge about pollutants that is present in water, air and soil that causes the environmental pollution, that leads the pollutants are causing to lead to the environmental pollution. So they will understand how environment is polluted by these pollutants. For solving engineering problems by applying the principles of science. So here we are giving number of vital features too, because here also no formulas are there, no derivation part, so no mathematical expression. CO12 mapping with PO7 describe the causes and effects of air pollution, water pollution, soil pollution and noise pollution. So they will learn the knowledge about the different types of pollution and understand the impact in socio-economic and environmental context for sustainable development. And here we are giving number of vital features too only, because here also no derivation part, no mathematical expression, no formulas are there. So we are giving number of vital features mapping with the CO12 to PO7 is. So here we are giving number of vital features too. So here when we come to the here syllabus, we are having 5 modules. Module 1 electrochemistry and corrosion, module 2 water technology, module 3 engineering materials, module 4 green chemistry and fuels, module 5 natural resources and environmental pollution. So module 1 is electrochemical cell. So what we are learning in this is about, we are learning here electrode potential, standard electrode potential and Calomel electrode Ernst equation, electrochemical series, and we learn about batteries, and we learn about different theories of corrosion, chemical corrosion, electrochemical corrosion, and how to protect the corrosion by cathodic protection, surface coatings, galvanizing technique, and here electroplating. And module 2 is water technology. So we learn about hardness of water, different types of hardness, temporary, permanent hardness, units of hardness, and here we will estimate the hardness of water by complex symmetric method, potable water and its specifications, and how we can go for treatment of water, the municipal water, drinking water by chlorination and ozonization, and we can purify the water here by ion exchange process, and desalination of water, that is removal of NaCl from water by reverse osmosis, and we will calculate the problems. So next here module 3 is engineering materials. We will discuss here about polymers, and here we will discuss about different types of polymerization reactions, and we will learn about plastics, compounding of plastics, and we will learn about different types of plastics here, polyvinyl chloride, Teflon, bakelite, nylon 66, and biodegradable polymers, and we will learn about elastomers, natural rubber, vulcanized rubber, synthetic rubbers, bunized rubber, thiol rubber, and we can learn about lubricants, characteristics of lubricant, mechanism of lubrication, different types of mechanism of lubrication, flash and fire point, cloud and pour point. These are the properties of lubricants, and oiliness of lubricants, and viscosity of the oils. And the fourth module is green chemistry and fuels. We will learn about the definition of green chemistry, methods of green synthesis, different types of methods of green synthesis, and we go for fuels, classification of fuels, solid fuels, analysis of coal, liquid fuels, refining of petroleum, gaseous fuels, about LPG, CNG, and we'll go for calorific value, different types of calorific value, gross calorific value, net calorific value, and we go for numerical problems. Next, module 5, natural resources and environmental pollution. So natural resources, we are going to discuss about classification of resources, living and non-living resources, and renewable, non-renewable resources, water resources, and here land resources, energy resources, and we will learn about alternate energy resources, and here environmental pollution, different types of pollution, air pollution, water pollution, soil pollution, and noise pollution. So these are the 5 modules we are having in course, chemistry course. We are having 5 modules. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.